Hi everybody. So today we're going to discuss the 2020 MCQ paper, physics. So I recommend trying questions from 1 to 10 first. After trying your best, listen to the discussion, then it's more fruitful, it's more effective. So let's see the first question. Dimensions of Planck's constant are, you know the equation, E equals hf. Now to understand this equation, let's look at an electromagnetic wave. If you look at an electromagnetic wave, these electromagnetic waves are comprised of photons, like so. The energy of a single photon is equal to hf. If we have a number of photons in an electromagnetic wave, the total energy of the wave is equal to nhf. Now you know that v is equal to f lambda, velocity of the electromagnetic wave, frequency of the electromagnetic wave, and wavelength of the electromagnetic wave, right? Then I can substitute f with v over lambda. Then I can say E is equal to h v over lambda. So remember these equations and analogies for future questions as well. So when I'm discussing a question, I'm not only focusing on the question itself, I'm focusing beyond the question, such that you'll be competent enough to answer another question, a wholly different question. Right, so I hope you understood this. So these photons are packets of discrete energies. This idea was really well explained by Einstein. So let's see. Let's come to the question. So E is equal to hf. E is energy of a photon. So what is E here? The energy of a photon. H means Planck's constant. F means frequency. So if I divide E by h, I get F. But what are they asking in the question? They're asking the dimensions of Planck's constant. So E divided by F is equal to h. What are the dimensions of energy? Yeah, force into displacement. Work done is equal to force into displacement. So force, so units of force times units of distance divided by frequency. Force, what are the dimensions of force? What are the dimensions of force? The mass times acceleration, therefore m L t minus 2. Dimensions of distance, L. Frequency, it's what? T to the power minus 1. You know that frequency is equal to 1 over time period. Then, you know, dimensions of frequency is equal to T to the power minus 1. I hope you can understand this. So what happens then? You get m L squared T minus 1. So you get what? M L squared T minus 1, right? Because this cancels off, so you get m L squared T minus 1 for the dimensions of Planck's constant. So what's the answer there? Second one. So second one is the answer. M L squared T minus 1. I hope you understood this. Right, the second question. Figure A shows the scale of a micrometer screw gauge when the spindle and the anvil touch each other. Figure B shows the scale when a metal sphere is properly placed between the spindle and the anvil. The pitch of the screw is 0.5 millimeters and the circular scale is divided into 50 equal divisions. Now many people memorize this concept of zero errors, positive zero error, negative zero error. I don't like that. You don't have to memorize this. Just consider zero errors as readings. Then you should understand what you should do. Should you add or subtract logically? So look at this. In this scenario now, this is the main scale side, millimeters. Zero can be seen, right? Zero can be seen, which means what? Obviously, there cannot be a deterioration in the anvil. Like if this is the anvil and this is the spindle, if it's deteriorated a bit, the spindle can come towards the anvil. Then the zero cannot be seen because I'm going beyond the zero. But now, as zero can be seen and there's a reading, that means I have a reading already. That means it's like placing a certain object between the anvil and the spindle. If I place an object between the anvil and the spindle, I get a reading, a positive reading. So that sees the reading here. So let's consider that reading. If you look at figure A, you can see definitely a reading. What is the reading? You can see the zero here and the third division here. Third division in the circular scale and zero of the main scale. And these in millimeters, remember that. So they have given the pitch of the screw to be 0.5 millimeters. You know, least count is equal to what? The pitch of the screw, which is 0.5 millimeters, divided by the total number of circular scale divisions, which is 50. So you get 0.01 millimeters for the least count. So if you multiply the least count by the coinciding division of the circular scale, you get the reading. That should be added to the main scale reading. So let's see that. So the initial reading then is now 0, which is the main scale reading, plus the circular scale reading, which is 0.01 times 3, which gives you 0.03 to be the initial reading. Now, this is like a situation where there's already an object. Probably due to rusting, this can happen between the anvil and the spindle due to collection of rust. There could be an additional reading, initial reading. So it's an extra reading. So that's not necessary. But now I'm placing another object. I'm getting a reading. So this rust is there. And then I'm placing an object whose thickness I have to measure. Then this reading initially is R1, second reading is R2. If I measure the final reading, it is R3. The final reading that I measure, I'm thinking I'm measuring the real thing, but I'm not. I'm measuring R3 to be the thickness of R1 plus R2. So if I subtract the final reading from the initial reading R1, I get the real reading. That means the real thickness of this block. I hope you can understand that. So let's see the final reading. Now we have the initial reading. The initial reading is 0.03. What's the final reading? Can you see 3 millimeters here? And then 3.5 millimeters. 0.5 goes. And then after that, you get the circular scale like this. The coinciding division here is 31. So first I have to take the main scale reading, which is 3.5 millimeters. Then I should add that to the circular scale reading, which is this number of divisions multiplied by the least count, 0.01 millimeters. So I get then 3.5 millimeters plus 0.31 millimeters, which gives me 3.81 millimeters to be the final reading, R3. So if I subtract the final reading from the initial reading, I get the real thickness of the metal sphere. Right. Okay. So what should I do then? Subtract 3.81 millimeters by 0.03 millimeters. Then I get the answer to be 3.78 millimeters. I hope you can understand this. Right, next question is the third one. The threshold of hearing of a normal human ear is 10 to the minus 12 watt per meter squared. This corresponds to sound intensity level of. Right. So you know beta, which is sound intensity level, is equal to 10 log the intensity that I'm looking for divided by I naught. What is I naught here? The threshold of hearing. We put the threshold of hearing here, that intensity relevant to threshold of hearing, and here the intensity which I'm looking for. You know I naught is equal to 10 to the power minus 12 watt per meter squared. So if I'm looking for the beta level of this intensity, what can I do? I should substitute I naught here instead of I. Now I can substitute any value for I here, but in the case I'm looking for the sound intensity level, when I hear an intensity of this much, which is 10 to the minus 12, which is the threshold of hearing, I should put I naught here as well. So beta is equal to then 10 log the intensity that I'm looking for is I naught, and the threshold of hearing, the intensity corresponding to that is I naught. So we get log of 1. 10 log of 1. What is log of 1 equal to? 0. So 10 times 0 is 0. So beta is equal to 0. 0 decibels. I hope you can understand this. These are very simple questions. Right. So let's come to the fourth question. The figure shows the velocity time graph for an object moving along a straight line. What is the average velocity of the object from t equals 0 to t equals 4 seconds? What can you say? Let's look at this. Now, they've given a graph, VT graph. And you can see it is 3 here, and it is 3 here, it is 4 here, and it is 1 here. Let's see. You know, average velocity, we average. What's the definition of average velocity? Yeah, the definition of average velocity is total displacement divided by the total time taken. So what's the total displacement here? You can see the area, which is 3 times 3 plus 1 times 1. This area of the square plus this area. So 1 times 1 plus 3 times 3. You get 10. So 10 is the area. Because the area of a VT graph gives you displacement. So what's the total displacement here? 10. And it's in meters because I'm measuring here in meters per second and time in seconds. Always be careful of the units, because I can put meters here only because meters per second times seconds gives you meters. When you calculate the area, meters per second is multiplied by seconds, then second per and second cancel off. Then the total displacement is 10 meters. What's the total time taken? 4 seconds. Then I get the average velocity to be 2.5 meters per second. Yeah, so that's the answer. All right, the fifth question. The figure shows a thin uniform rod AB of length L and mass M. The moment of inertia of the rod about the axis PQ parallel to the rod situated at a distance y is. So these are very easy questions. So you should understand the theory well in physics. You can really take some time and try to contemplate on the theories, really understand the theories. Things will start working for you. And always give some time for a question. Don't be in a hurry just to listen to an explanation all the time, like you can do your own work. Yeah, so give some time. You know, if a question is hard, you can think about that question alone. So when you think about a question alone, things start working. Right, so then fifth question. Now, you know, if I have an axis like this, and if the distance perpendicular to the axis is r, and I have a particle of mass m here, what's the inertia of this particle about this axis O? Suppose I have an axis O in the y direction like this, and I have a mass m at a distance of r from the axis at a perpendicular distance r. So what's the inertia? I equal to mr squared. Suppose I have another instant, we have the axis like this, and I have a mass m1 here, a distance r, and another mass m2 here at a distance of r. What's the inertia then? I is equal to m2r squared plus m1r squared. Then you get I is equal to m2 plus m1 r squared. Is that clear? Right. So you can understand, if I have so many other masses at equal distances from the axis, I should keep on adding the sum of their masses and then multiply by the common distance squared from the axis. So then I can say, look at this, if I have particles like this, m1, m2, m3, m4, at distances r1, suppose r, again r, 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 all at distances of r. What's the inertia equal to? m1 plus m2 plus m3 plus m4 times r squared. So you can see I is equal to what? Sigma mr squared. So remember this, sigma mr squared. That idea is very important. So look at the question again then. So here I have the axis PQ. Very simple stuff. And I have the rod like this. And the rod like this. And this is the axis PQ. So the distance to the particles of the rod from the axis is y. The distance to the particles of the rod from the axis is y. So I may be having mass m1, m2, m3, m4, and it could be not even, like you can have different masses here and there. The mass here could be different from the mass here. It doesn't have to be even. What matters is this, like I know I is equal to what? Sigma mr squared. So I can say, what's the total mass? So what is sigma m here? So you can say sigma m times r squared. What's the total mass here of the rod? M. What's the distance to that entire mass? R squared. But here they have given it as y squared. So my squared is equal to what? The inertia about the axis PQ. Right, so that's understood. The next one is the sixth question. The quark content of a proton and a neutron is, you know, up quark and down quark. The up quark is equal to plus 2 over 3 E. The charge of the up quark is equal to plus 2 over 3 E. Down quark's charge is equal to minus 1 over 3 E. So from these up quarks and down quarks, you have to construct the proton and the neutron, the composition of it, you can see. So look at the proton, like proton's charge is the positive charge of an electron. Now, electron is minus 1, the proton is plus 1. So it's equal to the positive charge of an electron. So what can you say? I have to construct plus 1 from these numbers for a proton. How can I do that? If I take 2 U's, I get plus 2 over 3 plus 2 over 3, which gives me 4 over 3. If I put a D here, I get minus 1 over 3. So overall I get what? 3 over 3. So 2 over 3 plus 2 over 3 minus 1 over 3 gives you 3 over 3, which gives you what? Plus 1. E. So this gives you the composition of a proton. A neutron, on the other hand, has no charge, 0. So I have to find a way to get 0. How can I find a way to get 0? Think about it. To get 0, now if I have plus 2 over 3, which is what? 1 over 3 plus 1 over 3. 2 over 3 is 1 over 3 plus 1 over 3. Then I better get 2 minus 1 over 3 is, no? Then these cancel off. So what is this one? U. What is this one? D. D. So U dt gives you what? The quark composition of a neutron, because the quark composition of a proton is UUD. Neutron is UDD, because 2 over 3 plus minus 1 over 3 plus minus 1 over 3. Is that clear? Yeah, so that's understood.